Good afternoon, everyone. My name is Rama Thirunamachandran. I'm Deputy Vice-Chancellor and Provost here at Keele University, and it's my great pleasure to welcome you all to this afternoon's lecture, inaugural lecture, I should say, and particularly warm welcome to members of Chris's family and other friends from outside the university who have joined us this evening. It's really nice to have you all with us. Inaugural lectures are really special occasions because they are in many ways a celebration of academic achievement of individuals, and tonight is no exception. To be appointed as a professor here at Keele is one of the high distinctions for an academic, and an inaugural reflects that distinction, and it's a public way of celebrating this promotion. In some countries, a professor doesn't actually become a professor until he or she has given their inaugural. Chris has been a professor for a little while here, so that we don't operate that system here, but it signifies the importance attached to an occasion such as this, the inaugural lecture. Now, Chris Exley, known to no doubt most of you in the audience, graduated in biology from the University of Stirling in 1985, and then stayed on at Stirling to do his PhD in ecotoxicology. He then carried on at Stirling as ICI Postdoctoral Research Fellow, so that's a little while ago, as you can see, because ICI is now split up into two separate companies since then. And he came to Keele in 1992. And having come to Keele in 92, he won the prestigious Royal Society University Research Fellowship in 1994, which he held for, I think, 5 years for the duration, before being promoted to a reader in 2002 to reflect the recognition of his achievements in his research. And in 2012, Chris was promoted to a chair. Chris's work and his main interests have been largely in bioinorganic chemistry of aluminium and looking at the effects of aluminium on human health. And he's going to say more about it because he's the expert and I'm not, so I'm not going to say any more about it. Other than Chris is going to take us on a whistle-stop tour, as the program says, of the natural history of aluminium and the unnatural future of living in the age of aluminium. He is, to many of us, known as Mr. Aluminium. I guess today I can introduce him as Professor Aluminium. And so can I welcome Professor Chris Exley to present his inaugural lecture, You Can Call Me Al.
Thank you very much. I just need to check that the mic is on. Yeah, thank you. Well, good evening. I gave my first lecture today at 9 o'clock. Seems a long time ago. See, we do work hard here in academia. We're not going to work hard this evening. I'm going to do my very best to entertain you in many ways, but to entertain you, of course, with a serious bent. I've been working on aluminium, well, next year it will be 30 years. I started my work in 1984. So clearly I'm not going to tell you about all that work today. I'm going to tell you a little bit of a story, really about why I work on aluminium and why perhaps you need to know about it, and perhaps why the wider world needs to know about it too. So I've called my talk, You Can Call Me Al, and I'm guessing that those of you who arrived a short while ago will know why, but we'll take that theme through the talk as we move on. I'm not going to mention what's happening over here. This is something for you to take notice of if you like. Once you get bored of me, you can have a look what's happening on the other screen. as any of my students will often tell you, I always like to start a talk or a new subject area with a definition of sorts. So what I'm going to do is sort of paraphrase a great Englishman, Samuel Johnson, who on producing the dictionary defined a lexicographer as a harmless drudge. So perhaps an aluminium researcher is a harmless drudge too. Sometimes it can feel like that. Sometimes it feels particularly exciting. Let's try and bring over the exciting side. Why aluminium? A little bit of background. First of all, the Earth's crust on which we walk is made of 3 elements: aluminium, silicon, and oxygen. So aluminium is the most abundant metal on the Earth's crust. It's the 3rd most abundant element in the Earth's crust. Paradoxically, it has no biological function at all. And I say paradoxically because all elements of any ubiquity at all, and many that are trace and scarce, have biological functions, and yet the most ubiquitous metal on the Earth has no biological function. That, for me, is sufficient to spend one's life researching aluminium, because it's a paradox, understanding why is that the case. So ubiquity combined with absolutely no biological function. Neither a bacterium nor our advanced state ourselves require aluminium for any process whatsoever. This figure that I produced about 10 years ago now is in many ways the raison d'etre for my research and for my research group over the last 20 years or so. It's our raison d'etre for a number of reasons. One is that it helps us to understand here in the lithospheric cycle how the Earth's crust most abundant element, or metal, is cycled efficiently, essentially through, as mountains grow and mountains are dissolved by rain, aluminium gets cycled back within, essentially, the lithospheric cycle, the non-living part, the inorganic cycle. There is a very small movement, potentially, of aluminium into the living cycle, the biotic cycle. But literally 99.999999% of all of the aluminium of the Earth's crust does not enter the biotic cycle. So this is a fantastically efficient process. One of the possible reasons why all these people looking for life on Earth, on other planets, you've got to take a lot of things into consideration. And the ability to keep aluminium potentially in an inorganic phase, not in the organic phase, in the living phase, may be one of the prerequisites for life as we see on Earth today. Maybe. Oops, I'll just go back if I can. I want you to notice here, of course, in red, human intervention. So there has been an impact on the lithospheric cycle by man. For example, through acid rain, acidifying the catchments, through intensive agriculture, also acidifying catchments, processes which allow aluminium to come out of those inert stores, potentially becoming available for living things. But most of all is man extracting aluminium from the Earth's crust, from aluminium, silicon, and oxygen, and heralding what I like to call the aluminium age. It's relatively recent in terms of life on Earth. It's incredibly recent. We're talking about the modern aluminium industry, our ability to take aluminium out of its ores and make aluminium metal and make aluminium salts, just over 100 or so years old. You know, I like this term, the aluminium age, because when I went to schools, probably when many others here did too, we learnt about the Iron Age, the Copper Age, the Bronze Age. Well, without question, we live in the aluminium age today. I will try to show you the myriad ways in which our lives are impacted, or the ways in which we are exposed to aluminium in our everyday lives, just in this very short period of time. But I won't be able to cover even a small fraction of them. But you cannot avoid aluminium in your everyday life, living in the aluminium age. So a consequence of living in the aluminium age is that more aluminium is getting into that biotic cycle. A consequence of more aluminium getting into the biotic cycle is that we are also exposed to a burgeoning amount of aluminium, an increasing amount of aluminium. The potential danger there is that as more aluminium goes into the living cycle, there are very few ways of aluminium to get out of the living cycle and back into the inorganic cycle. So as it goes in there, it just gets recycled and it accumulates. And aluminium is accumulating in the biotic cycle over time. And it is accumulating in you and I too. So that's what I've called the body burden of aluminium. Everyone here, in every one of your cells, has got at least one aluminium atom, and that aluminium atom is not serving any positive function that we have found out, and potentially it's biologically reactive, so your bodies are coping with it at all times. You are expending energy living in the aluminium age simply by the fact that you have aluminium inside of you. So let's have a look at a few ways that contribute towards the body burden of aluminium. The way we look at this is this balance between exposure to the metal, to aluminium, the burden, where it is, where it goes, and how we excrete it, how we get rid of it from our body. So we need to look at that particular balance. So exposure, an easy one, what we drink. Actually, historically, tap water has had some bad press with respect to aluminium because we do use aluminium salts to clean tap water. And so people, and it has been true in the past, the aluminium content of tap waters has perhaps been unnecessarily high because we haven't controlled these processes well enough. But actually today, generally, the aluminium content of your tap water, if you get it supplied from one of the major companies, it should be relatively low. It should be about 50 parts per billion. So in tap water per se may not be an issue, but in everything else that we drink, you will find it. From whatever your favorite tipple is, whether it's tea or coffee, whether it's, like mine, wine, whether it's beer, even, you know, God's liquor, whiskey. Unfortunately, you will be taking in aluminium, and probably more than would be the case, you know, for example, in tap water. So we cannot avoid it. The way in which we take it in, via the gut, potentially across the skin. This is an area of real lack of knowledge. If you have a bath in some aluminium solution, do you absorb it across your skin? Historically, we'd have said, oh, no, no. But actually, the truth of that matter is that probably we do, and we just need to understand it better. In terms of the lungs and the nose, if we inhale vapor, something with aluminium in it, then it can get access to us, as we'll see in some other examples. So, quickly, water, yes. Your diet, definitely. Whatever you take in here, it will definitely have some aluminium in it. What type of diet has most? Don't worry about chips, Chips, not necessarily a bad thing, you know, daddy or chips, still choose chips. But processed food, you know, the great versatility of aluminium, the success of aluminium living in the aluminium age means that it's been one of the most useful food processing agents that we have invented, and we have added it to everything. And I haven't got time to go through all these examples with you, otherwise I'll run out of time before we even get close to the end. But take it from me, in processed food in particular, we add aluminium to help the processing of it. Aluminium is also there as a contaminant. We'll see some examples later. Aluminium is also there, inverted commas, naturally, because a product has been grown somewhere where the aluminium can get from the soil and into the plant. Tea is a great example of that. You know, us Brits, we didn't want to trade with the Chinese, so we made India and other Ceylon and Sri Lanka grow tea for us. But we made them grow it in areas where it was unsuitable, and soon the soils became unsuitable for it, they became acidified, and tea accumulates aluminium. Luckily for tea, it's not toxic to tea, because tea just happened, or at least some types of tea, happened to have the type of chemicals in the leaves, in the tissues, which could bind aluminium and prevent its toxicity. But just an example of why it's there, because of growing in certain areas. If you like a cigarette, I noticed a couple of people outside earlier just having a quick cigarette before they came in. Well, by the time you go for your next pee, the aluminium from your cigarette will be in your urine, you'll be excreting it. That's how quick the aluminium in tobacco, when it's burned and you inhale it, gets into your body, and some of it is excreted via your urine. If you like a spliff too, it's not after 9, but we can mention it, it'll be just as bad. Cannabis has a lot of aluminium in it. This is why I'm a little bit against the use of cannabis as a medicinal drug, because people don't seem to accept how much aluminium there is in it and how quickly it can get inside you. You know, the significance of olfaction or the lung, anything that goes via the nose has direct access to your brain, to the hippocampus, does not have to go through the blood-brain barrier. Anything that goes via your lung does not have to go via the liver, your main detoxification agent, so it can get to your blood-brain barrier and your brain even more quickly. You know, it's not a coincidence that people take recreational drugs in that manner. And talking of recreational drugs, they also either contain or in some way predispose people to aluminium. So our work on heroin addicts showed that heroin addicts excrete large amounts of aluminium in their urine. We actually tried to reproduce this in the lab, thinking, well, they must be chasing the dragon. When they chase the dragon, they burn the heroin on aluminium foil, and they suck it up through a straw or a pipe or something of that sort. You can imagine the problems we had with the Home Office doing this in our lab, but we did, and we managed it with Roger Bloor, who's not here, but it was some interesting times chasing the dragon in the bioinorganic chemistry laboratory. Cocaine is known to be contaminated with aluminium. So snorting cocaine is a great way to get aluminium into your hippocampus. Just remember that next time. This recreational drug of the rich and famous. That's why perhaps we'll start to see higher levels of some types of disease, maybe, who knows, from this sort of cocaine habits that we have in the present day. You've probably heard of antiperspirants. Antiperspirants are fantastically effective at preventing us from having these rather unwanted smells, stroke sweat under our arms and other places, because aluminium salts are fantastic antiperspirants. Don't believe what the antiperspirant industry tell you. It's not because they just simply block the sweat gland. That's rubbish. They actually inhibit sweat production in the sweat gland. They inhibit the activity of the sweat gland, and they're very, very effective at it. And you're putting a gram of aluminium under each arm every morning. If, like me, by the way, you decide that that's what you need to do. Antiperspirants, a really interesting way. We know some of that aluminium gets across the skin. I was asked by Procter & Gamble many years ago to write a report for them, which we later published in a scientific journal, about antiperspirants. And my conclusion was, well, if you're going to use an antiperspirant, and you know, I reiterate, I do, don't use the spray, because the spray means it's going up your nose, it's getting straight into your brain, potentially a good way of getting aluminium into your brain via antiperspirant use. Across the skin can take quite a bit longer, short, slower, perhaps less problematic. Drugs, prescription and over-the-counter, you can't avoid them. Aspirin, buffered with aluminium. Antacids, fantastic way of controlling stomach pH. There are no better drugs than antacids made of aluminium hydroxide for that purpose. We use it because it's effective. Of course, it's cheap, that helps too, but we use it because it's effective. Perhaps more worrying is, you probably weren't aware, this is the main drug given to people with Alzheimer's disease, Aricept. It also contains aluminium. Worse than that, and this is unpublished as yet, worse is they add it to the drug because they want this nice yellow color. So an aluminium lake, which gives a yellow color, is used to color a drug which is given to people with Alzheimer's disease. And some of you will already know there is this link between aluminium and Alzheimer's disease. Sounds a little complacent to me. We found out a few years ago that there's quite a lot of aluminium in sunblocks and sunscreens. In fact, if you follow World Health Organization guidelines for an average day on the beach, you will put 5 grams of aluminium all over your skin every day on the beach. Aluminium can go from there into the surface layers of the skin. Aluminium can promote oxidative damage. There's a very interesting relationship, isn't there, between melanoma, the malignant form of skin cancer, and the increasing use of sunscreens and sunblocks. It's almost a straight line. I know, correlation doesn't mean anything, but it is a straight line relationship between increased use of sunscreen, sunblocks, and melanoma incidence. Which country has the greatest amount of melanoma? Australia. Who uses the most sunblocks, sunscreens per head? Australia. Anything to do with aluminium? I don't know. Probably one of the great scandals, I think, is the high level of aluminium, significantly high level of aluminium we find in infant formulas. The breast milk substitutes that we feed to our children are just born. The concentrations of aluminium in these products are several times higher than we would accept for tap water, and yet we give them to our children. We're about to publish again on this to try to reiterate this problem, to actually start to ask for legislation against this, not because I know that it's definitely bad, but because we need the precaution. We need a precautionary approach to loading the most vulnerable members of our society with aluminium at the youngest age. When a child takes an infant formula with aluminium, their gut is not yet fully developed, so more aluminium goes into the blood. Their kidney is not fully developed, so less is excreted. Their blood-brain barrier is not fully developed, so more can access the brain. We are giving our children a burst of aluminium in their early years. Is that good? The topical area indeed is vaccination. Actually, we've been using aluminium as an adjuvant in vaccines, both vaccination and allergy therapies, for 80 years. Actually, most vaccines would not work without the aluminium. You would not be able to get a sufficient immune response with the amount of antigen that is used, the amount of the thing that causes the disease in the first place. So aluminium is incredibly immunoreactive. Aluminium salt, aluminium hydroxide, aluminium hydroxyphosphate. What's even more interesting is we don't actually know how it works. Why is aluminium so immunoreactive? And we have an MRC-funded project on this at the moment. It's actually taken me quite a long time to realize the significance of looking at this. And I've been, as you know, working aluminium for nearly 30 years. This is an area of real interest to understand aluminium in living things, aluminium in vaccinations. So, living in the aluminium age ensures our body burden, so we cannot avoid it. We have this body burden of aluminium. Where does it go? Where is that aluminium? Yes, it's actually everywhere. Wherever we look, we find it. You know, we recently completed a study of the largest of its kind anywhere ever of the aluminium content of 60 human brains. A fantastically interesting study producing really fascinating results. But the one interesting thing to find is that there's a lot of aluminium in the brain. It's not evenly distributed, it's focally distributed. In some areas of the brain there's almost nothing, in other areas there's quite a lot. It's very difficult to get any judgment from that. Bearing in mind, you know, when you do have the privilege of working with human brain samples, you normally have less than a gram. Well, the gram you got to work with could have been a gram that doesn't have any aluminium in it, and the next gram next to it could have a lot of aluminium in it. So it's very difficult, but you know, we know these things now. You know, the aluminium industry for years has been telling people, oh, aluminium doesn't get in the brain, don't worry about it, it doesn't get in the brain. It's ludicrous to make these sorts of suggestions. It doesn't mean it causes anything because it's in the brain, it just means it's there. Maybe a potential for deleterious effect, but it's there, that's the important thing. And everywhere else. One really interesting result that some of my students, where are we, produced just this year, undergraduate students. She's not here, but anyway, she designed the product herself and she measured the aluminium content of sweat in healthy volunteers, other students from the university. How surprising how much aluminium is in sweat. I mean, I was surprised. So clearly it's a good way of excreting aluminium, but the fact that it's there starts to tell you a little bit more about where aluminium also is in the body, where it's accessing, and where it's getting out, and perhaps also how antiperspirants may or may not work. So it's there, it's in all of these possible areas. There isn't an area that it isn't there. Classically, yes, there's a lot in the bone. We know there's some in the brain. There's got to be some in the liver because it's a detoxification. We know there's a lot associated with red blood cells. We know it's associated with the vasculature. It's everywhere. It's in your hair. We measured hair this time. It's in nails. We measured nails this time. It's clearly in your urine. So how do we get rid of it? How do we remove aluminium? Because, first of all, we do, of course. We're not. Every time we're exposed to aluminium, it's not just going inside of us and staying there. Actually, the majority of it is being removed. So if we ingest aluminium, we remove most of it that we ingest in our feces. So the vast majority of aluminium comes into our body in different forms and goes out down the toilet, which is good news. It's going to get recycled again, by the way, because that's biological. It's going to end up in another animal somewhere or even your neighbor. But you got rid of it at that time. That does get in the blood, again, the vast majority of that is being excreted in your urine. And actually, the urine is one of the best non-invasive ways of trying to understand how much aluminium there is in your body. And it's a method that we use a lot of. So it's unfortunate, but we have fridges full of human urine. And you know, we have to work with that. One of my students down here is just learning the fun of working with human urine at the moment. Other areas, hair, I just mentioned, it's excreted in hair, in nails. When you rub your skin and you lose a few skin layers, you lose aluminium. And as I just mentioned also, it's going to be coming out in the sweat too. So you are excreting that aluminium load, but some of it is retained. A proportion is retained, and what we know is that over time, that each and every one of us has more aluminium in us today than we did yesterday, and you will have more in your body tomorrow than you do today. And this relationship seems to work on a more or less linear basis up to the 7th or 8th decade, something of that sort. So are we bothered? I don't know. Some of you can guess the answer, that we might be bothered. I was asked, as part of the celebrations of 200 years of the birth of Darwin, or 150 years since the publication of The Origin of Species, to write something for Trends in Biochemical Sciences about how natural selection is involved in why aluminium is non-essential, why it has no role in biological systems. And I came up with my own, here's Darwin, whoops, go back, that gave a bit too much away there. I came up with my own tree of life here. Oh, this is Darwin's tree of life, and I came up with my own version here. And essentially the short story behind this is that it is only since the advent of the aluminium age that we, and not only us, but everything living to a certain extent, is having to evolve in the presence of an increasing or burgeoning amount of aluminium. Evolution isn't something that happened in the past, it's something that happened today, of course, it's happening now, and we are now evolving in the presence of what I would call a burgeoning body burden of aluminium, a burgeoning amount of biologically available, biologically reactive aluminium. So what are the consequences for the future? Aluminium is incredibly biologically reactive. Ask a fish that was killed in an acidic water by aluminium whether or not aluminium is dangerous. Ask someone who died of dialysis encephalopathy because of aluminium going into their brain whether aluminium is neurotoxic. Of course it is. These are not questions, these are known. We know about the biologic activity and reactivity of it. What we don't know primarily is what happens with the sort of exposure that most of us are experiencing on an everyday level. And what will happen when that exposure gets more and more and more? What will happen when the aluminium age really kicks in? Is that something that we need to worry about? Because evolution essentially works by the basis that some organisms already are predisposed for something that's coming along later. And they have the good fortune to survive that. Will we survive that? Do we have, the genetic makeup which means that when we're exposed to something which we potentially have not been exposed to before, or any form of us has not been exposed to in biochemical evolution, will we survive it this time round? Are there any signs already of this increased body burden of aluminium? Are there any signs of us responding to it? So that's what the next slide is all about. So each of these conditions has been linked strongly, weakly, whatever, has been linked to your body burden of aluminium. This is just a few. There are many possible conditions that have been linked through good scientific papers to exposure to aluminium. And of course, most notoriously is Alzheimer's, as you see here on the screen. Solutions. There must be a solution. Mustn't there? A solution to living in the aluminium age. You're not going to get rid of aluminium. It's great. Most of the time you think aluminium works for us. We found it, invented it, created myriad products from it. We use it in fantastically different ways. It's almost impossible to conceive that we could suddenly say, no, that's it, no more aluminium. So we need a solution. And that's what myself and my group have been working on for the last 25 years or so. What is the solution? Come on, somebody say it. So what's the solution? It's not Ghostbusters, of course, but it needs something similar. What is it? You need to make the sign in the sky. A bit like Batman, but we thought of it first. The sign of a silicon-rich mineral water in the sky. And out will appear aluminium man. And who knows, the solution to living successfully and effectively in the aluminium age. So my wife, who's in the audience, will remember 2 consecutive Sundays 7 or 8 years ago, could be longer, when I got up on a Sunday morning, or sorry, not I, a healthy volunteer, got up on a Sunday morning, not having any breakfast, and drank at about 9:30 1.5 litres of a silicon-rich mineral water, and then collected his urine over the following rest of the day, and then did that on the next Sunday as well. And what did we find? We found that immediately after drinking my silicon-rich mineral water, this healthy volunteer produced a spike of aluminium in their urine, which suggested to us that drinking a silicon-rich mineral water made you pee aluminium. Where the hell is that coming from? It's coming from you. The relationship between silicon and aluminium I've already mentioned. The Earth's crust is made of aluminium, silicon, and oxygen. My PhD was all about silicon protecting against the toxicity of aluminium. Silicon is the natural antagonist to aluminium. Drink a silicon-rich mineral water, you pee aluminium, like it or not. So this formed the basis thereafter of a lot of research in my group. My PhD student, who's now finally getting ready to submit her corrected thesis, Sam Davenward, spent over 3 years working on this, looking at how healthy volunteers, people with Alzheimer's, and indeed a small project on people with Parkinson's disease, how each of these groups handled silicon when taken in as a silicon-rich mineral water, and how it influenced their excretion of aluminium in their urine. We also looked at a number of things, but Sam did some fantastic work, extremely good results. I'm going to show you just very briefly some of the results that she found. But essentially what you're looking at here is either silicon or aluminium, and we also measured iron and copper in the urine over time following drinking silicon-rich mineral waters, in this case in healthy volunteers. And the striking thing I want you to look at is the way in which the black and the red mirror each other. So when you drink the silicon-rich mineral water, you pee silicon and aluminium together in the urine. So we've got some really striking data of this sort for 20 healthy volunteers, males and females. That is still waiting for Sam to finish the corrections for her thesis so we can then write that up. She's got real myriad of fantastic data that really has never been seen before. So the potential efficacy of using silicon to potentially protect against the toxicity of aluminium is a real possibility. This is also Sam's work. We had the opportunity to extend a previous study. Back in 2006, following the work that my wife and I started, looking at silicon excretion in a healthy volunteer, we worked with Peter Krome in those days on looking at whether or not if we gave people with Alzheimer's disease, we could get them to excrete aluminium following drinking a silicon-rich mineral water. And in 2006, we published a paper which shows, yes, it is possible. So we were then able to follow that up with a much more longer-term study with people with Alzheimer's disease and also using their carers or spouses as an age-matched control group. The alarming result, well, we were able to show that the body burden of aluminium in people with Alzheimer's disease fell during a relatively short period. So they had to drink 1 litre of mineral water every day during this period. Believe you me, getting just ethical approval for someone for Alzheimer's disease to drink a mineral water you can buy in the shops is in itself a task. But then, you know, the other aspects of it, the logistics of it, so we needed 10,000 litres of mineral water. It actually came from a Malaysian company called Spritzer, who don't sell their water in Europe, but were willing to give us the water. So we had to bring it over in a ship, and we had to use a room in the Leonard Jones to fill with mineral water. It's logistically a much tougher problem than it looks. But the results are starting to show some very interesting insight. Not only, as I said, are we able to reduce the body burden of aluminium in people with Alzheimer's disease by just asking them to drink a silicon-rich mineral water. You don't do anything else different. You live your normal life. But, and quite incredibly, we were also measuring cognitive performance. And in 3 of the individuals, over such a short period of time, they actually showed clinically relevant improvements in cognitive performance over that time. Listen, it means nothing at this point. Doesn't mean aluminium causes Alzheimer's, doesn't mean it contributes towards it, but it's an indicator of what potentially is possible if we were able to extend this type of study beyond a relatively short period of time. And that's what we need to do next. We need to get perhaps targeted groups of people, perhaps people predisposed as opposed to people having Alzheimer's, to take silicon-rich mineral waters over long periods of time. Let's test the aluminium hypothesis of Alzheimer's disease. Is it really involved or not? If someone sitting in the audience, I'm pretty sure they don't, has got £1 million, I can answer that question for you. We know the experiment, we know how to do it, we can answer it yay or nay, but perhaps the answer is just way too dangerous. We don't really want to know that, do we? We want to know that it doesn't, but what would happen if we showed that it did? So, just to take us through it, if there's something strange in your daily bread, do you remember when the white loaf appeared? Some of us are old enough, we know that. Remember the sliced white loaf? Why was it so white? It was white because it had aluminium sulfate added as a whitener. So, something strange in your daily bread. You're worried that it might go to your head. We are. Don't run to the bathroom for a dose of salts, Epsom or something similar. Or down to H&B's, Holland & Barrett's, is it? For a jar of malt. That's what my mum used to give me when I was little. I don't think parents do that to children anymore, but, you know, malt. Simply remember that bottle of Volvic, Fiji water or Spritzer, other mineral waters, silicon-rich, are available, apparently. And I will call you Betty. Betty, when you call me,
is the music going to fade away?
yes. We're not going to overdo it.
2 or 3 incredibly impressive things on that. One is absolutely bang on time. The target was 7:15, so very, very impressive. But I think all of us were captivated by your enthusiasm for your topic, and that absolutely came over. But the other thing I asked at the beginning was, given that there's a mixed audience, experts and non-experts here, how technical is it going to be? And I don't think there was anybody in the audience who failed to understand all of that, but also to really appreciate the significance of it as well. I'm going to invite the Deputy Vice-Chancellor and Provost to return for a final presentation to Chris.
This is just a small memento to mark the occasion, Chris,
thank you very much.
and congratulations.
Thank you.